Today I will discuss with you what is the expression of energy stored in an inductor or a solenoid or coil. Okay, this is a coil or inductor let current I is passing. Well, what about the magnetic field which is produced by current? It is Ni. N means number of turns per unit length of the solenoid or the coil. This is H. When the H it comes in the free space, and here it becomes B, because free space of permeability mu naught, permeability of the free space, when it is attached with H, mean with Ni, that becomes B. Now if there is B, there will be flux with each turn which is linked. The magnetic field is there because magnetic field is because of current, and because of magnetic field there will be flux, magnetic flux with each turn. Flux is what? B into E, so that it is equals to mu naught N I, which is B into E. This is magnetic flux. Okay. Then what is the total flux with this solenoid? Total flux. Then you have to find what are the total turns. With one turn, with 1 unit length, the turns are N. If the length is L, what are the turns? N into L. With one turn, this is magnetic flux. And magnetic flux with the whole solenoid, that the flux with one turn multiplied by the number of turns. So total flux becomes mu naught N into N, N square I A into L. This is the total flux linked with the coil. The flux proportional to flux, okay, linked with the solenoid. It is proportional to the current which is passing. So, because this is a single coil having a self-induction, and proportional sign can be replaced by a constant L. L is called coefficient of self-inductance. So if you compare this expression with self-induction and current, what is the self-induction? Self-induction means I is I and L means mu naught N square AL. So L equals to mu naught N square A into L. This is coefficient of self-induction. Okay. Now, the Faraday law. If there is some flux which is linked with the coil, okay, and induced EMF or the induced voltage or the induced potential, there will be induced potential if there is a rate of change of flux. If magnetic flux changes with time, then there will be induced voltage and induced current. One current which is flowing, okay, there is one current which is flowing, that is of the battery current. Battery current induces the B. B means magnetic flux. Now if that magnetic flux changes with time, there is another induced EMF, it develops, which induces another current in the same coil, different from the battery current. This is because of Faraday law. Faraday law states that whenever flux changes with time, there will be a induced EMF and induced current. That induced current will be different from the battery current. Okay. Now this what is phi m? It is equals to Li. Substituting it here, then induced EMF is minus d by dt into Li. Then induced EMF equals to minus L di by dt. So there will be induced EMF in this coil, but the reason of the induced EMF will be when this current, this is battery current, not the induced current. This is battery current. When battery current changes with time, then induced EMF will be produced. I mean, like you are having a solenoid and a battery and a key. When you just switch on the key, just switch on, what happens? The battery current starts increasing because current takes some time to reach from 0 to its maximum value. Like maximum value is 1 ampere or 2 ampere. Maximum value is 2 ampere. Then current takes some time to reach from 0 to 2 ampere. Okay. It now happens that current instantly becomes 2 ampere here. No. It takes time. And during that time, when the battery current is increasing, then this current changes with time. With respect to time, battery current is increasing, means changing. That induced EMF is produced. Induced EMF induces another current in the same coil. That is the induced current. That induced current then will oppose this current because the Lenz's rule, negative sign. Right? But just soon after, when you press the key and the current is increasing and current takes some time to reach the maximum value, when the current reaches to maximum value, then after what happens? Current becomes constant. It is not changing with time. Induced EMF becomes 0. Induced current becomes 0. Means no opposition. So opposition only will be just when you make the circuit for a very small time. And again, when you when you release the key, this battery current starts decaying. When the battery current starts decaying, again I decreasing with time, again induced EMF is produced. Induced EMF again induces a current, but now that current again opposes the battery current. What is the nature of battery current? Battery current is decreasing. Now it opposes, it induced current flows in the same direction. Why same direction? To oppose that node to decrease now. Okay, that is giving the opposition. So at the time of break, it flows in the same direction as the battery current, but at the time of make, it flows in opposite direction because then it was increasing with time. And induced EMF is produced, induced current opposes the growth of current, and then it flows in opposite direction at that time. Okay, E is equals to minus L di by dt. Minus sign means opposition, Lenz's rule. Now, from here, that potential is equals to, definition of potential is work upon charge, and work becomes equals to potential into charge, right? Potential into the charge. Now work done, there is a self-induction in the coil. Because of self-induction, current, when the current is rising or when a current decay, then there it meets the opposition. Because of the opposition, work is done. So what is work done? This voltage here means induced voltage and charge. What is induced voltage? Just here, L dI by dt. So induced voltage is L dI by dt. So it is L dI by dt into charge. Current equals to charge over time. Charge equals to current into time. Substituting, dq here. So it becomes I into dt. dt cancels. So this is a small work done when current increases by small value in the coil where there is self-induction. Now what is the total work done when current rises 0 to I? So work becomes L I di, I square upon 2. So this is the work done, and this work done becomes energy, which is represented by U. U is equals to L I square by 2. Okay, you know very well the value of L. Value of L is mu naught n square AL, and energy equals to 1 by 2 L Li square. Substituting L here, so it is 1 by 2 mu naught n square AL I square. This is the energy expression. Okay, and you know very well B equals to mu naught Ni, and I from here, I equals to P upon mu naught N. Substituting it here, this I. Substituting this I here, I taken I from this expression. So U becomes half mu naught N square AL. I square mean B square divided by mu naught square and N square. Okay, now what happened? N square cancels. Okay, mu naught cancels with 1 mu naught, and energy becomes 1 by 2 L into E. Okay, L into E, then B square upon mu naught. So this is energy in case of energy in an inductor, half L A B square over mu naught. This length into area. This is the volume of the conductor. So if I replace it with V, volume of the conductor, and volume is taken to this side, then energy per unit volume. Energy per unit volume is called energy density, magnetic energy density in case of inductor. It is half B square upon mu naught. So very important expression for energy density of an inductor. Okay, thank you. So if you find any difficulty not understanding any formula, any equation, then you can write, you can tell me writing in some words in the description box. Okay, thank you.